My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Relevel. So in this video, we are actually moving to the very last leg of the series for relational models and talk about ER models to relational models journey. So here, in the start, you must have seen that we talked about the 12 EF chord rules. And then we also talked about what a relational model is, what are the few attributes and things that you need to know about, and as well as we also talk about integrity constraints. So the last thing in for which we actually did all this discussion was how do we take a ER model and how do we convert it into a relational model, because that is very very relevant, right? Relational model is actually the thing we are using in the real world right now. But how do you start this entire journey? Let's say you have to design a database. So you first get the requirement from the user, right? You have to generate relevant ER diagrams for that, right, which try to represent the relationship between the entities, right, and what all attributes you require. And the moment you have that, it's equally important to have the knowledge of how do you convert those ER diagrams, that ER model, to a relational model. So this video is specifically going to be focused on that, of how do we go from using a ER model to a relational model. Okay. So as we know that ER model can be represented using ER diagrams, right? Which is a great way of designing and representing the database design in more of like a flowchart form, right? You must have seen that in the ER modeling videos, we were drawing proper flowcharts, right? And kind of, using arrows and diamond blocks, rectangular box to represent the relationship between the entities and what all attributes we are using. So ER model is actually a very popular way to represent the database design. Whenever we are in the early phases, ER models help a lot to get a more systematic and a presentable view of the entire database system. It is very convenient to design the database using the ER model by creating a ER diagram and then later converting into a relational model. If you would directly take the user requirement and then convert into a relational model, then it's a little bit of a tricky job, right? It's a little bit of a difficult job because the process to go from user requirements to relational model, it's not that easy. Okay, so if you will see over here, what you have is you usually have user requirements in the start, right? Using those user requirements and directly moving on to a relational model, designing a schema, designing table and columns and fields, it's not very easy. It can be done, but it's not the very smooth process. But instead of that, if you will first take up user requirements, okay, then you convert ER diagram, which is far easier to do. Okay, and then if you move on to relational models, okay, then trust me, the transition is actually very smooth and it's a more fun process to get a more realistic view of the databases as well. Okay, so remember that not all ER model constraints and components can be directly converted into a relational model. Okay, so it's not like whatever you have in a relational model can always and forever be converted into a relational model. Some parts of ER models can be converted, some part of ER models are a little difficult to be converted into or transformed into a relational model, but it's not like you can never get any idea, but it's always like an approximation schema can always be derived using ER model. Okay, so what we will do is, to understand the best way, like we always do, we'll take a few examples of ER diagrams and we'll try to convert it into a relational model schema. Okay, hence which eventually means that we are just creating tables into RDBMS. Okay, so that's what pretty much the overall concept here would be, that we'll take a few ER diagrams and then we'll convert it into RDBMS. Okay, so here what you'll see is that we talk about entities. Always remember that entity becomes table. So whatever in your ER diagram you are representing as entities, they are nothing but the tables in the relational model. So see, it says entity in ER model is changed into tables. Okay, or we can say that for every entity in ER model, there is a table created in relational model. Okay, let's say you remember the school system, right, where we have a school, where we have a class, subject, teacher. Those are nothing but the table that you will also create. Okay, and remember, the attribute of the entity gets converted to the column of the table. Okay, so let's say if I was saying something like this, let's say I have a student entity and it has the attributes name, roll number, age. Okay, that is nothing but this roll number. So this is the student table. The name of the table will be the name of this. It is name and it is age. Okay, so whatever you see like this, so this you can see entity became a table over here, and the attributes of the entity basically became the columns of the table. Okay, so that is how you always do the conversion. Okay, so that is what it says. Entity in ER model is changed into tables, or we can say that for every entity in ER model, a table is created in the relational model, and the attributes of the entity basically gets converted to the columns of the table. As you can see, it's the same example. A student with the name, a table with the name student, for this will be created in the relational model, which will have 4 columns: ID, name, age and address. And here you can see ID is given underline, and we just read that if you have an attribute which is underlined, that means it's the primary key. So for my table also over here, if I mention this, then this will be the primary key. Okay, so that's how this concept works. Now here, one thing we have in the entities was entity, like in the ER diagrams we had entity that we sorted out, we had attributes that also we sorted out. The third thing we had in the ER diagrams was relationship, right? We used to use a diamond or a rhombus to represent a relationship. So how do we convert that? It says that in ER diagram we use diamond, rhombus to represent a relationship between two entities. In relational model, we can create a relationship table for ER model relationships too. So whatever relationship you have, right, between two entities, that relationship also can be created into a table in the ER or in the relational model as well. Okay, so here you see an example that in this ER diagram we have two entities, teacher and student. Okay, and there is a relationship between them which is teaching, right? Teacher teaches student, correct? That is how the relationship is. Now if I have to actually convert it into a relational model, we know that entity gets mapped to table, hence there will be definitely a table for teacher and there will be definitely a table for student, which are nothing but the entities, right? And all of those attributes for teachers and students will become the columns of teacher table and student table. Now an additional table will be created for the relationship, which is known as student teacher. Okay, or like you can give any name you want. Okay, the table will hold the primary key for both the student and the teacher, okay, in basically each and every row, to discuss the relationship, to tell which teacher teaches which student. Okay, now if there is an additional attribute related to the relationship, then they can also become a column. Okay, for example, teacher teaches students, but there is also an attribute for subject, right? Relationship also tells the subject name, so you can also put that as well. Okay, and obviously you have to use proper foreign key constraints in order to set the relationship table. Okay, let me actually give you like a proper example to understand this. Let's say you have this teacher, which is an entity, students, which is also an entity, and here it says teachers. All right, now what happens is teacher has an ID, okay, teacher has an age, teacher has a name, teacher has a phone number. Okay, and ID is marked like this, and here student will also have an ID, which is primary ID. Student will also have an age, student will also have a name. Okay, and let's say student also have an address. Now this is your ER diagram. And this you have to convert into a relational model. Here, let's say you have first the teacher table, right? In the teacher table, you will have the ID, which will be the primary key because it is marked underline. Then we have the name, then we have the age, and we have the phone number. Similarly, student is also an entity, so corresponding to that there will be a student table. Here ID is marked underline, so that means it's a primary key. It will have a name, it will have an age, and it will have an address, right? Now what will happen is we have to also represent this relationship. So for that we will have another table. Let's say we call it the student teacher table. Here I will take, you remember I said we will take the primary key of both the tables. So this is what is teacher ID. Here you will put student ID. Okay, so let's say the teacher IDs were 5, 6, 9, 12, 13, and student ID was, let's say, 101, 102, 103, and 104. So the relationship is, let's say here again it depends what kind of relationship it is. It could be a one-to-one relationship, it could be a many-to-many relationship, it could be a one-to-many relationship, it could be a many-to-one relationship. Let's say it's a one-to-many relationship. That means one teacher is teaching multiple students. So it could be something like this. Let's say the teacher with the ID 12 teaches student with 102, 104, 105. Okay, so this is very well representing the relationship, right? The teacher relationship with the student relationship, right? Teacher is teaching the student. Similarly, let's say it may happen that over here you have teacher number with the ID 5 and it is teaching roll number 109, 102 and 113, right? So this is the table used to represent relationship, right? And that is what it says in the ER diagram as well, that to represent the relationship you can also use tables. Okay, tables are very well equipped to represent relationships as well. Tables do represent the entities, that is what we know for sure, but also know that tables can be also used to represent relationships as well, and they do the task very well. Okay, you can see this very sufficiently suffices to help us to understand how does a teacher is related to a student, and even all the mappings, if it is one-to-one, one-to-many, many-to-one, or many-to-many, even that is very well executed and represented in this table. Okay, so that is what you always have to keep in mind, and that is how you have to practice this concept as well, right? The concept itself is not very difficult, but it all comes with practice. Okay, let's say now next time what you can do is you can try out an example where, let's say, you have a employee or like an employer. Let's say we have hospital, right, and patients. Okay, or like hospital and let's say doctors. Okay, hospital employees, right, doctors, employees, hospital employees, and like has a lot of employees who are doctors, right? So this is kind of like a relationship over here, right? Or it's like employees, I think, is a good relationship to understand. You can also keep it like organization hires employees. Like if you want, you can take this example as well, right? And the relationship is that they hires employees in this case. Okay, so now if you have to represent a relationship, you will have to make an organization table, employee table. Like here, this is just to play with, right? You can add as many things you want, you can add as many attributes you want, you can make it as complex, you can make it as simple. I would recommend to start with a simpler example and then make your way up to the very idea. If you will start with the very first hard example, then it will demotivate you a little bit and you might not be able to learn. Okay. But remember, this is very, very important, right? I cannot stress enough on the importance of knowing how to convert a ER model to a relational model, because that is what we actually do in the real world as well, right? So if there's a concept that you're doing theoretically and you have a real world application in the industry, it automatically becomes very important to know about that topic and to understand that topic. Okay, because that gives you a more wholesome idea and makes you more comfortable with both ER model and relational model. So if you don't remember relational model, right, if you don't remember the syntax and if you don't remember the shapes and the way we design ER models, I would recommend just go back, right, watch the ER modeling videos again, see what we were doing over here, right, and then come back here. That is why I said in the very start itself that to know and to fully grasp these set of videos on relational model, ER model should be absolutely clear, because both of them are quite interlinked to one another. We actually don't use ER model, right, in the final stages of databases, but ER model is definitely required to get converted into the relational model. Okay, so I hope this set of videos was helpful for you and you could understand what we were doing. The idea again is very simple, that you have an entity is table, attribute is column, and relationship can also become a table itself. So it's all about practice now. Since the concept is very difficult, it's morely focused on how much you can practice, right? And again, you can read more points to talk about the importance of ER model and relational model, right? But I hope the overall set of idea is clear to you, and I hope I was helpful in making this topic a little bit easier for you to understand through multiple examples that we took. Okay, but stay tuned, we'll definitely come up with some more videos where we talk about in depth about these concepts more to have a better understanding. Till then, thank you so much for attending this video.